companies today, instead of trying to drive the cars in real-life scenarios, they generate situations and then train the AI, autonomous driving AI, in that black box. Drug discovery, Google itself has recombined a large number of inorganic compounds and molecules and open source them in an effort to find out new compounds that can solve a lot of the health problems. Right? So a big help in pharma. We are able to have personalized education in the education sector, where without enough teachers, students do not have specific focused attention for themselves. So instead of giving a one-size-fits-all for a class of 50 or 100, we are able to personalize education. All of this has been the effect of generative AI. And when you look at all of this, you see, oh my God, what is this, right? There is this huge thing called AI, and here we are trying to understand the basics of what is happening at all, right? And of course, when we are at parties or meeting some uncle, they'll be like, hey, what are you doing on this? You'll be like, yeah, I know GenAI. But be honest, do you really understand it? Or have you just tried out ChatGPT and Bard? So today what I'm going to do is to give you a gentle introduction to GenAI, where we look at some of the deep philosophies underlying language, why it's making such a big deal. We look at how GenAI itself is created in comparison with some of the existing technologies. And also towards the end, I will show you a small app that I built using just the basic knowledge and a basic LLM, a large language model that was already available with Google. So it's very simple to get started. And as I know with others speaking today, they're going to get into the details of generative AI and other topics. About myself, I do a bunch of stuff in and around Google Cloud, got a bunch of certifications. Though I'm not working for Google, I do some work for Google with respect to their certifications. In one of the courses currently on Google Cloud Skills Boost, I've created them. We're going to be doing more of that, some of the labs on Google Cloud Skills Boost, etc. All right. Now let's talk a little more about LLMs itself. So what can it do? In the case of an LLM, you put in some kind of English text, and then it spits out some other English text for you. Why is this such a big deal? Why are all these companies clamoring for the next big LLM, the next big technology? Why are they pushing it so hard? Why is there so much happening in the whole OpenAI company where somebody's fired, immediately hired, he's rehired, and all of that, right? There's a lot happening, not just in the technology, but in the politics and the business around GenAI. So why is this such a big deal? It is because language itself gives us a very special place in the universe. In the entire cosmos, we stand out as a species that is able to do things that nobody else can. If you compare our core, right, if you compare our core, our DNA is about 60% exactly the same as that of a banana. Okay? What separates us from a fruit to where we are, right? It's about 40%, that's all, right? Our core DNA is pretty much exactly the same. If you compare ourselves with chimpanzees, we are about 98.8% exactly the same. And yet, we are able to achieve so much. We've sent rovers to the moon. We've, in a world that is out to kill us with viruses and volcanoes, bacteria and hurricanes, we are still able to not only survive, but thrive and do so much. We've got autonomous cars. We've got spaceships. We've solved so many different diseases like polio, which is going to be eradicated soon. Smallpox has been eradicated. So much we've done. And all this being just marginally different from a chimpanzee and a little more different than a banana. What is the underlying reason for this? I would contend that one of the biggest things that separates us as humans from the rest of life or even non-life is language. Okay? Even though animals can communicate in a rudimentary level, really the ones that are able to build concepts, to build abstract ideas like mathematics, we are able to do space travel, all of this comes from our ability to have language. And today, language is seen as a substitute or as a signal towards intelligence. In fact, the Turing test, which checks whether, the way the Turing test, if you guys have seen also the movie called The Imitation Game, the way you do the Turing test is you keep one person who is interacting with two other entities. One is a human, one is a machine. And the person has to guess which one is a machine and which one is a human. How do you interact with these two entities? Through a screen where you are conversing in text, in language. right? So the Turing test of whether somebody is intelligent is based on language, right? In fact, all our exams, all our evaluations, all our tests, the exams that you write, are based on language. And you would see that a lot of people who speak well, even if they aren't specifically more competent, they tend to do better because of the ability to convey, communicate. So language itself gives us this ability to communicate, which is powerful to start with. And then we build this ability to record this. So whether we are carving them in stone or etching them in papyrus or writing and printing it on books, or today if you're just changing bits on a little magnetic substrate with electricity, all of this information we are now able to record. And there is vast amounts of information, right? There are zettabytes of information, which is many, many trillions of gigabytes and terabytes. So huge amount of information that is being very quickly gathered. In fact, about 90% of all data that we have today has been collected in the last 2 years, right? And this continues to increase. The same statement stood true in like 2000, in 2010, because every day we're taking photographs and videos, and the amount of data that we collect is growing rapidly. All of this, how is it stored? How is it conveyed? Through language, right? That's the way that is conveyed to the next generation, the next viewer, the next reader. And it's building on this that we have been able to achieve some amazing feats, right? As Isaac Newton says, what he has achieved is by standing on the shoulders of giants, right? He's read other things by people. We read what Newton has written. Einstein reads what Newton has written, and then they build on top of that. So language, therefore, conveys knowledge and wisdom, okay? So any system that is able to understand natural language allows us to dig into this huge body of knowledge. And this is one of the reasons why, even when you have little kids, one of the first things you teach them is language. How do you speak? How do you convey? Because that becomes a starting point for learning a lot of different things. So like a little baby, like a little human, if you are able to achieve the same thing with machines, what will we be able to do, right? We can send all of the information we have to a machine and have that respond to us in intelligent ways. So language by itself is amazing, and let's keep that idea there, let's park that while we look at something else. When we look at our brain, it's not very different from a bowl of dal tadka or a chicken curry bowl. Okay, it's not. What is it? It's a bunch of chemicals. There's a soup of some kind. There's some protein. And now if you add 2 batteries into a bowl of dal or chicken curry, you've effectively got the components of our brain. A little electricity running through a little bit of liquid and protein is essentially what our brain is. But it doesn't stop there, right? The same things that are in our brain are also there in our hands and legs, right? The same tissues, similar electricity with neurons and all of that. But the brain achieves something much larger, right? It is able to take this substrate of very basic elements and bring in ideas like consciousness. We can think in abstract terms. We are able to think of ideas like gravitation, that we are not the center of the universe, that there is a solar system, that we are able to go till then, right? And with recent lunar launches in India and all of that, we are able to do very, very complex things. Sending a mission to the moon, a rover to the moon, is not just throwing it there, right? You have to take into consideration the gravitational pull, how it is going to rotate around the Earth until it gets like a slingshot effect, and then it gets into a next orbit and the gravitational pull of moon until it is able to slowly land on its surface. Very, very complex stuff. And we've been able to do this over and over again. Also, one thing I'm always proud of, and I have to mention, so 2 of my classmates from engineering are part of the ISRO mission to send Chandrayaan to the moon. So 2 girls in my class, they're involved in all of these missions. And always be proud about saying that out loud. So, thank you, I'll convey that to them. So we are able to take this very simple idea of chemicals and little electricity and build amazing things. And this is what we call an emergent property. Even though we don't code in these ideas like consciousness, it arises automatically from the system. Okay? And seemingly, we can do that with language. Let's just try it out. So this is something I've borrowed from a paper by Stephen Wolfram, where we know the distribution of characters in the English language. E is very prominent. It occurs a lot. T is there, A is there, something like Q, J, X and all. those not very much. If you randomly pick out letters from this, in this distribution and put it out, we get a bunch of letters, nothing much over there. Let's add a space now, right? Assuming it's also a character. Now we start seeing word formations. Then let's add the distribution length of typical English words and say now we can start to see it's starting to look like English, but it's still jumbled characters. Okay? Now we add 2 grams or n grams, which is a combination of certain letters that occur together. Like Q is always followed by U. Right? Now we can again see words are starting to form. Now if we all do the same thing for words, there are certain words, for example, on, the, right? They occur together. If you bring that together now, you can see language starting to form. So starting from a very random approach by attaching letters and words together, we start to see language form. Okay? So it's a very interesting idea that maybe language isn't all that it is cut out to be. Maybe we aren't superior in this world, but we've just figured out a way to connect language in a way that conveys meaning. If we take the last one and say, let's combine the words in existing ways that we know. If I say, for example, today is Saturday, that is a word, that is a sentence you recognize, and therefore you see it as a fact. What if I combine the words in completely different ways? Today is something random, right? Today is a festival. Or today is the 13th day of Toulouse. We don't know what that is. But maybe those words in those random new orders create new ideas, which becomes creativity, right? So creativity itself is a combination of words in new and different ways. And of course, words leads to intent, intent leads to action. Therefore, words themselves carry a lot of power, which is why today we don't use certain words in certain contexts because they have a very negative impact on society itself. Okay? So, is intelligence and creativity merely an emergent property of words strung together? Apparently, that is it. Okay? We as humans are not very separate from the rest of the world, not in our DNA, and seemingly now not even in our language, which seem to separate us. Right? Seemingly, we can do this with machines by recombining words. So I was talking to somebody, and this person said to me, Vishnu is the god of preservation. So I'm not extremely religious, but I understand the concepts of this, right? And this has multiple concepts here. The concept of a god, that we are not alone in this universe. Somebody had to have created us, our existence, right? There is a story of where we are going, all of that. There is the idea of preservation. Why? Because in Hindu philosophy, as you know, there are like these cycles of creation. There is the Krita Yuga, Treta Yuga, Dwapara Yuga, and then the Kali Yuga when it all stops, and then Shiva destroys everything, and Brahma again creates in the next cycle. Right? So a person who's going to speak this conveys that they are intelligent by having these words put together. So when somebody says this, we ascribe intelligence and knowledge to this person. Right? Now, it was not Professor Yashpal who said this. The person who actually said this, by looking at, remembering something that was told to her, was my little daughter. Okay? So she's 2.5. I would say she's cute, she's smart, but she's not that smart. Okay? She doesn't understand concepts like God and preservation and cycles and yugas and all of that. But a fact, when this girl, having read it somewhere in a book, or somebody read that story to her, she repeats it to me. If it was anybody else saying it, we would say that person is intelligent. Right? So if you assume, or if you don't assume who the person is, words in connection have a lot of things that they can convey. Right? So language itself. So any system that can ingest language and then reconstruct it will express knowledge, and knowledge applied will be like intelligence, and these words applied in very different ways will lead to creativity. Okay? So we've parked this idea now, let's park this idea now of how language becomes central to a lot of the things we do, the facts that we know, the creativity we'll have in the future. Okay? So with that, what are AI, what are LLMs, large language models? How are they created? What can you do with it? Let's look at that now. And the best way that in conversations I've had with people, the way to convey this is to compare with what was there before. Okay? So originally there were databases. Databases stored facts. You put in some information, whether they were right or wrong. Whatever is stored is the fact, and then you're able to retrieve that. So you ask a question like, hey, what is the sales figure for a time in the past? you're able to get that exact number, and you have that information. Okay? So if you are plotting it on a graph, it is as if you are having an x-axis, y-axis. You say, at the point where x equal to 20, what is y? You're able to draw the graph and say, at this point, when x is 20, y is a specific number that we know. Right? Say 1.2 million or whatever number it is. It's a very specific detail that we are able to pull out. But when we ask questions about data that we do not have, there is no answer. Right? The system doesn't create new information. So this becomes a little bit of a problem, because today when we have large amounts of data, you can't search through all of that very quickly.